All right, so we're going to kick off the second sort of batch of talks, and all right, I think we had some great big picture inspirational stuff to begin with. Now we're going to get down and dirty with some code and begin with the hippest of hip code that there is, which is of course React, but specifically we're going to look at server-side React. And to tell us all about that, from Facebook, we have Forbes Lindesay.
Okay, I'm going to be talking about server-side rendering. Let's start off with why you should care about server-side. Hopefully, some of the previous speakers have already convinced you, but in case they haven't, server-side rendering makes your websites machine-readable, which is great for search engines, but it also might enable other use cases that you might not have considered initially. It also allows you to get initial content displayed as fast as possible, because what you're sending down from the server is ready to render, has the content there, has the data there, and can be instantly displayed before the client has time to fetch and parse and execute all of your JavaScript and then make more AJAX requests, more web requests back to your server. It also allows you to show something even on older or unsupported devices. So if there's errors in your JavaScript, if any bugs occur, at least if you've got server-side rendering, there'll be something visible on the client. It also allows you to support lower-end devices. So on lower-end devices, running JavaScript can be really slow. So even if your app could run on a device, your entire client-side code could run, it might not be worth sending them that JavaScript. They might get a better, faster experience if you just make them post back to the server every time they interact with your app. This is actually how most people see Facebook. This is our basic mobile app aimed at low-end smartphones and feature phones, and this is by far our most popular interface into Facebook. It's a plain HTML app. It's got some small amounts of JavaScript, but really very little. And it's actually really fast. It's a really great experience in lots of ways. So if we've decided we want to render on the server side, we have basically three options. We can write two separate apps, the server-side version that people see initially, and then just replace it with a client-side implementation once the JavaScript is loaded. But most people don't have the engineering resources to build two separate apps. So let's scratch that option. You could just write a server-side app, and there are lots of cases where this is the right approach. Don't use any JavaScript, don't have any front-end stuff, just build a server-side app and let everyone use that. Great if you're a predominantly content-based website. So if you're a news site, seriously consider this approach. But I'm going to talk more about richer applications, partly because they're more interesting, in my opinion. So with that, we're left with one approach. We'll write a broadly client-side app, and then we'll figure out how to get that app running on the server, how to run the app during page load, and send down a serialized string that's the resulting HTML. To do that, we need some abstractions, because some things aren't the same on the client as they are on the server. So we need to abstract away the URL and the navigation. Those are different on the client and the server. We need to abstract away rendering. One renders to a string, the other renders into the DOM. We need to abstract away how the data fetching happens, because that's different on the client and the server. And we need to abstract away how updates, interactions, form posts, that kind of thing happen. Let's start by talking about navigation. On the server side, we're rendering at a given URL, and then on the client, we're rendering at the current URL, whatever's currently in the address bar. On the server side, we allow the application, our application logic, to trigger a redirect, trigger navigation via a redirect. On the client, we also allow it to trigger navigation, but this time it's updating the address bar in the URL, and it's updating the history, so it's updating what happens when back and forwards navigation are triggered. We also have an extra step in the client in that we need to be able to re-render the app every time the URL changes. So if the user presses the back button or the forward button, we need to be able to re-render the app with that new URL, the new address. There really is a great library out there already that does this abstraction for us. And you should use this whether you're using React or any other framework, really. It's a library with many implementations that all implement the same interface. So if you call their create browser history API, you get back an object that represents the browser's history and uses HTML5's push state to update the URL bar and keep the URL bar in sync. But you can also, on the server side, call create memory history. And what that gives you is essentially a mock implementation, which is great for tests, but it's also great for rendering on the server side. It means we can take our client-side app that was built expecting a browser history, and we can give it a memory history and just put in the initial URL as the location that we've got from the web request. And the API it has lets you push a new location into the history, updating the address bar, lets you replace the current location in the address bar without adding an entry to history. It lets you trigger back and forwards actions, and it also lets you listen for changes in that location. So by listening for those changes, you can then re-render every time that function is called. So this process end to end, on the server side, we receive a request in Node.js. We create the memory history with the request URL in that history already, and we give that memory history to our app to render. If the URL in that history object changes while we're rendering the app in that initial render, then the app has attempted to trigger a redirect, and we should actually return a redirect response directly as the result of that request, which will trigger the browser to load the new URL at the new location, and then we can re-render with that new content. On the client side, we're going to run our code on page load. We'll create the browser history object instead of the memory history. We'll give that browser history to our app to render it, and then we're done. The app will just handle it from there on in. The next thing we need to abstract away is the rendering. So this time on the server, we're rendering to a string, and on the client, we're rendering into the DOM. That's really all there is to the rendering abstraction. I know I said I was going to talk predominantly about React, but firstly, if you're not building a React application, if you've built, perhaps you already have an application designed to work with DOM, or perhaps you're using a different framework, there's a great library called JSDOM. And JSDOM is an implementation of the WHATWG, DOM, and HTML standards for use in Node.js. Now what that means is that it implements all of the APIs that your browser would commonly provide, all the ones that you'd expect an app to use, but it implements those in purely JavaScript in a way that works in Node.js, which means you can run it on the server. It's very powerful, and it can be adapted to work with pretty much any framework. So let's dig into some code. If we imagine our app as a function which takes everything that differs between the server and the client, then we know we'll be able to run it on both the server and the client, providing we implement those interfaces. So here we've accepted a window object and the history object. And we might potentially want to accept other options in the future once we have abstractions built out for data loading and so on. And what we're going to do is we're going to take the history object, we'll listen for changes to the location. Every time the location changes, we'll update the DOM to reflect what the content should be on that new page. Using this on the client.js to actually run our app is really simple. We just create a browser history, we load our app, and then we call the app with the window object and a freshly created browser history. So that's very simple. That we could have skipped out the steps and got the same thing. But the key is that now we've got this on the server side, we can render this a little bit differently. So we're loading JSDOM and the create memory history this time instead of create browser history, and we're loading the app.js. We'll pick a simple constant as our layout file. So this is just some HTML, the bit of your HTML that's constant. And then if we imagine something like an Express.js web server or really any kind of Node web framework, then we're going to get given some request object with information about the request. We've got a function that gets called with that request. And in that function, we can call JSDOM give it some HTML, and it will create an environment for us, a virtual browser, if you like. We can then give that virtual window object, along with a memory history, to our app. It will render into the DOM. And once it's done that, we can simply extract the inner HTML of the container element that it's rendered inside and send that to the client. So we'll replace the placeholder in our layout with the content that we've rendered into the DOM. Now let's look at React. So React is a JavaScript library for building user interfaces. And it has a highly declarative API, which means that we can render it directly into a string. We don't have to worry about these heavy DOM APIs. This is much more lightweight, it'll be much more performant. So since React models everything as a complete render every time, complete re-render, that's the approach there. React diffs what was there and what is now there to create the new, to update the DOM. So you just re-render everything. So given that it's doing that, I've decided to represent my app simply as a function from location to some React element. And the React element there can contain a lot of the interactivity, a lot of the functionality of an app. And we'll just simply call this function every time we want to re-render our app for a new location. So now on the client, very much as before, we're going to create a browser history. We'll listen for the changes to the location. Each time we get a new location, we're going to render that React app. So here we're using the React DOM library, which allows us to render a React application into a DOM node. And we're going to render that into the container element on the page every time the location changes. On the server, we'll start by loading the React server module, which is very much like the React DOM module, except it's intended for use on the server. We'll load the memory history again, and we'll load our app code. We'll use a layout, just like before, that's a simple string of HTML with a placeholder. And then when we get a request from the server, we'll create our memory history. We'll listen for that initial location. And once we get the location, we can call React server.render_to_string to render the application into a string. We can then replace the placeholder with that string and send it to the client. So we now have a React application that will render both on the client and on the server, and that will handle things like HTML5 push state and all the nice things that we need there. If you're using React, you can use React Router as well. React Router is a really high-level wrapper around the history object and around React. And it gives you support for things like nested views, a much nicer routing API, and it has support for rendering server-side and client-side, and it has really great documentation on how to do that. So I'm not going to go into the details of how to use React Router now. I suggest you look it up if you're building any kind of React application at all, even if you don't plan on doing server-side rendering. It's a really great implementation of routing. Let's talk about data fetching. So on the server side, we can read straight from the database. But on the client side, our requests are going to be via some kind of AJAX. On the server side, we can get user info directly from the session. We've presumably got some kind of session system in a typical web app, so we read the user info straight out of that. On the client side, the user info gets attached to any requests we make, assuming we're using cookies. But it's not directly available in the browser unless we go to the trouble of making it. So if we want our client-side code to be aware of the user, we have to provide it. Crucially, the server needs to know once all of the data is fetched. It needs to know at what point the app is ready to render and at what point we can then render it and send it to the client. The client, by contrast, needs to be able to render partial results. We want to be able to show loading spinners for the bits of the UI that we haven't yet loaded the data for, and at the same time render the bits that we have got the data for. So that's the key difference between the client and the server that we're going to have to represent somehow. Now, one option here is to skip this entire step, is to render just the shell of your application on the server. This works really well if you need high scalability. So by rendering just the shell, you defer all of the work of rendering the details of the UI that are personalized to the current user and the current request. You defer all of that to the client, and you let their device handle it. You can then have a really simple static server serving up that shell, and then users will hit your API, which is likely to be much more stable. This also allows you to get something displayed fast. So you might want to defer loading of things that are going to be slow to compute. And then you can load interactive components later, load the details later. But as we've discussed, there are times when you don't want to do that. So if you do want to render the entirety of your app server-side, make the whole app work without JavaScript, then you need some abstraction for your data fetching. And my recommendation here is to create the highest level abstraction you can for your data layer. Make all your requests flow through a single point somewhere in your application. And by doing that, you can tell which requests are in flight. You can tell how many are in flight and when they're finished. And this will allow you to figure out when you're ready to send the application to the client, when you're ready to send the response. You should also make sure your data loading is declarative. You don't want to continually be writing very procedural code that says, fetch this data, then render this bit of the UI. You want to be saying, this bit of the UI requires this data. So with that in mind, I've built a library that implements this, that provides these kind of guarantees, and it's called Bicycle. I'm not necessarily recommending you use this. It's just a prototype, really, and I'm only using it on a few small hobby projects. But Bicycle lets you define a schema in a fairly declarative way, and then expose that schema on a REST endpoint. And then from the client, it lets you subscribe to parts of that schema. So on the client side, we create a new instance of the Bicycle client. And that Bicycle client is our caching layer, is the layer that knows about which requests are currently in flight. So we'll have one of these per application, per render. It then lets you subscribe to some given part of the state. So here I've represented my query as an object. So I've said I want to load to-dos, and I want the ID field, the title field, and the completed field out of each to-do entry. And then I've said, call this function every time the result of that query changes. Now, the first time that function is called, there's not actually any data yet. So it'll just be given an empty object and a loaded value of false. And eventually, it will get called with the full result set, with all of the information in there, and loaded will be true. And it might get called at any state in between. There might be points at which it gets called when some of the to-dos have loaded but not others, or where some of the fields on some of the to-dos have loaded. Which means that we get that client-side behavior of rendering whatever we have so far. So we get to render the parts of the application we have loaded and render loading spinners for the rest. And then once the new data comes in, we'll automatically re-render. Lets you unsubscribe from the subscription, fairly simple stuff. And it also has built-in support for handling updates. So you can send all of your updates through this single point as well. And if you send an update through the Bicycle infrastructure, then it will automatically refetch any data that's changed. So it handles that side of things as well. On the server side, the first thing you can see here is we're loading in the dependencies. We're then creating a session store. So Bicycle is actually a stateful protocol, unfortunately. It uses that to figure out what content the client currently has, so it knows which bits need to be sent, which bits have changed. And then we expose the schema that we built over this Bicycle endpoint. So here we're saying mount the Bicycle middleware, the Bicycle server, at the /Bicycle root. We give it a schema, we give it a session store, and then we give it a function which, given each request, tells us the context in which to execute the query. So here we're fetching the user out of the request and putting the user in context, which allows the schema to make decisions about whether that user is authorized to access a given piece of content. This also has support for rendering on the server side. So what we've done here is created a Bicycle loader, And the bicycle loader takes the schema, the session store, again, and a function which, given a client, renders the application. So here we've taken a client and a location. We call our app function to render the application with that client and location. So then when a new request comes in, we call the bicycle loader with the context for that request, with the location for that request. And eventually it will return to us a fully rendered tree of HTML, string of HTML, sorry. When it comes to connecting this into React, I wanted to focus on other things, so I haven't talked too much about this. But React has a context feature, so if you're trying to build something like Bicycle from scratch, you should read about that. This helps you avoid global variables. So what this does is let you have some element at the top of your tree of React components that specifies a context, a value, some value in context, and then anywhere in the tree beneath that, you can fetch out the value from context. So instead of having a global variable, instead of declaring your client as a global variable, you can put it into context and still access the client from anywhere in the tree. Then the other thing to think about when you're connecting React applications to data layers, to data storage, is that you can use containers or connectors. So you create a higher level component that takes a query and some presentation component as arguments, and then returns a new component. And there's a great article on that called Mixins Are Dead, Long Live Composition, which goes into more detail. So very quickly, how do we handle updates? Form post is the way to go. This has been supported on browsers since the dawn of time. Simply specify a URL to post to and a method, which can be either post or get. We have an input element there with a name and a button to submit. And this will work in any browser and will send that data up to the server. Now the problem is that on the client we can do better. If we have JavaScript, we can run faster than that. So my suggestion is build a more abstract, build a higher level form that calls some method that is implemented both on the server and the client. So in this case, we can imagine building a higher level form which on the client calls into a bicycle update method, and on the server simply posts back to some URL, which in turn calls that bicycle update method. And this will allow us to use that form and have that form just work both on the server and the client. When it comes to more advanced interactions, consider whether the interaction you're attempting to make work on the server and the client is actually navigation. So a lot of elements, a lot of changes that we think of as mutations, as stateful actions, are really just navigation. So things like show hide buttons that show and hide sections of the UI. Make that a link, and then sure, on the server, if you don't have JavaScript, you'll just miss the fancy animations, but it'll still work. You'll still be able to press the button to say, show this bit. You can always have some fallback JavaScript for those critical interactions where there just is no built-in browser functionality for what you're trying to achieve. But be aware that not all users will have even any JavaScript enabled at all. Closing thoughts, why you shouldn't have listened to me and should have the last 25 minutes, I'm running over I think, back. Search engines these days run JavaScript. So the machine readable element, is it that important? Maybe not. If you render on the server side, that initial page that people see isn't that interactive. None of the JavaScript's there yet. They can't interact with it anyway, so I'm not sure it's that useful necessarily in every situation. It depends on your application. And running on the server side uses extra resources. So if you're trying to scale to lots and lots of users, then it's not always your best bet. So when you're building an interaction, you've decided you want to run on the server and the client, the things I would suggest you consider in order. Will the server-side implementation do? For example, links for navigation, they're good enough. You don't then need to implement something separate for the client, just use that. Can you enhance the server-side interaction with JavaScript? For example, something like a form post, you can just use a server-side component that works out of the box and then enhance it with some JavaScript, improve it, make it faster. Can you get away with not implementing this for server-side users? So some features just aren't that critical. They aren't that important. Maybe with those, it's fine to just say, you know what, people who have JavaScript enabled will get this feature, people who don't won't. Animation is a great example of that. Pretty much all animation is not that important for people who are going to send posts back to the server for most interactions anyway. And then finally, if an interaction is really critical and none of these other things are an option, then can you write a small bit of JavaScript separate from your main application code that makes just that feature work correctly? I'm Forbes, and thank you for listening.